Hello everyone, welcome to the solution of LeetCode problem 542 named 01 matrix. In this problem, we are given a two-dimensional matrix and we have to return the distance of the nearest zero for each of the cell. Now the distance between two cells sharing a common edge is 1. This is the pretty straightforward problem statement, but at the first glance, it might seem little bit of complex or misunderstanding. Now, I will explain the problem statement and the solutions in the next section. Here, to understand the algorithm, we have taken this example. Now, this is a 3 by 3 matrix, and the first 3 element is 0, 0, 0, second element is 0, 1, 0, and the third element is 1, 1, 1. Now, we have to find the distance of the nearest zero for each of the cell. Suppose currently we are at this cell 0. So here, what is the distance of the nearest cell which is equal to 0 from this cell? It is 0 because the cell 0 is itself containing the value 0. Similarly, for this 5 cell, all of them will be 0. Now suppose for this cell 1, what is the distance of the nearest cell which is 0? It is 1. The nearest cell which is equal to 0 is this, and this. So the distance will be 1. Now, suppose for this one, what is the nearest cell which is equal to 0? It is this, and the distance will be 1. For this, the nearest cell which is equal to this, and the distance will be 1 again. So for this cell 1, what is the nearest cell which is equal to 1? What is the distance? We have to go 1 unit up and 1 unit left. So the distance will be 2. So here, this matrix represents the distance of the nearest zero for each of the cell. I hope you understood the problem statement. Now let's see how can we solve this problem. Here, to solve this problem, we will use the BFS algorithm. Basically, we will use the multi-source BFS algorithm. So let's visualize how the multi-source BFS basically works. Suppose here we had a source, here we had a source, here we had a source. In the first iteration, the first level BFS will visit all of its adjacent node. Again, it is the first level iteration and it is the first level iteration. The BFS will visit all of the cell of the adjacent node. Now in the second level iteration, the BFS will visit its all of the node into the second level. It is for all of the source node. In the third level iteration, BFS will visit all of the node in the third level and so on. So basically this is how the BFS works in the multi-source manner. Now let's see how can we solve this problem here. Now we have to find the nearest distance of the cell which is equal to 0 for each of the cell. Can we think it reversely? The distance between 0 and 1 is equal to the distance between 1 and 0, right? So here we can think it in a reverse way. Suppose for this cell 0, what is the distance for this cell here? It is 1. Instead, we think it the distance between the 1 with 0, we will calculate the distance between 0 and 1. This is the basically a tricky intuition. Now, for each of the cell which is equal to 0, we will store them as the starting point of the BFS. and we will iterate the BFS in a level by level order. Now, suppose for this 5 cell which is equal to 0, their distance to the nearest 0 will be 0 because they are 0 itself, right? Now, we will start the BFS from this 5 cell. So here, if we start the BFS from this 0, it can go right, down, up, and left. Up is already visited, left is invalid, so we can go right and down. So if we go right, it is the first level. If we go down, it is the first level. Now, suppose for this 0, we can go up, left, right, down. So here, for this 0, we can go only down. So it is the first level. Similarly, for this 0, all of the positions is already computed. For this 0, all of its 4 direction is already computed. And similarly, for this 0 as well. Now, suppose for this one, we can go up, right, left, and down. So here, the only valid move is into the right. So here, it is the second level iteration. Now, for this one, we can go down, it is already visited. For this one, we can go left, it is already visited. So far, this initial matrix is converted into this matrix by using the multi-source BFS algorithm. And this is how we're gonna solve this problem. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named update matrix, which has a two-dimensional matrix as a parameter. Now we are calculating the dimensions and the number of level is initially 0. Now we are taking a n by m matrix, which is the visited array, which will store which element I have visited so far. Now we are taking a direction array and we are taking a queue of pairs. Now for each of the cell, if the element is 0, we have to insert it into the queue and mark it as a visited because this will consider as the starting point of the BFS, which is the multi-source BFS. Now, this is the BFS algorithm. While the queue is not empty, we are calculating the size of the queue and increasing the level. Now, for each of the level, for each of the element, we are storing the front element of the queue into a variable and removing it from the queue. Now, we have to check into all of its 4 direction. So here, the new x will be direction of I dot first plus front elements first. Similarly, the y will be direction of I of second plus front element of second. And if x and y become invalid or the current x and y is visited, we have to simply continue. Otherwise, we have to assign the level into the matrix x and y and mark it as a visited and insert the value x and y into the queue for the next iteration. Finally, we have to return the matrix, which is modified. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.